In this example, we want to build a model for the volume of a right circular cylinder inscribed inside a sphere of diameter 8 meters as a function of the height of the cylinder. All right, so let's try to visualize what's happening. So I have a right circular cylinder, which is basically a can, inside of a sphere. So we can think about that as like a ball. So this is a three-dimensional setup that we have. We have a can inside of a ball, a cylinder inside of a sphere. But what can be helpful is to instead think about this as a two-dimensional representation of the three-dimensional situation. Here is an image that represents the two-dimensional representation, where imagine sort of looking at it from the side. We have this rectangle inside of a circle. Now we were told that the sphere has a diameter of 8 meters. So that also means that the radius is 4 meters. So that means from the center of the sphere, or in our case, the two-dimensional representation from the center of the circle, the radius is 4. So the distance from the center to any point on the circle has to be a length of 4 meters. Well, I could take that center point and go either perfectly to the right to identify the radius or straight up. But because I'm trying to connect the idea of the cylinder inside the sphere or the rectangle inside the circle, I'm going to choose to go from the center of the circle to one of the vertices. And I'm going to think about that as a length of 4 meters. All right, so that being said, I wanted a model for the volume of a right circular cylinder as a function of the height of the cylinder. So my primary equation here is going to be about the volume of the cylinder. So the volume of a cylinder is pi r squared h. And I want this to be a function of the height. So the variable that I'm going to need to eliminate is r. So I'm going to need to get rid of the r variable here because I want this to be a function of the height, and height is the variable h. Now let's make sure we know where these variables are labeled on our diagram. This is the radius and the height of the cylinder. So here I'm going to go ahead and label the height of my cylinder, or in this case my rectangle. So this entire height here is h, and then the radius is of the cylinder is here. So this is the radius of the cylinder, and this is the height of the cylinder, because the primary equation, again, is on the volume of a cylinder. Okay, so now I'm going to need a constraint equation. Whoops. So my constraint equation, or my secondary equation, is going to have to be some equation that relates the variables little r and little h together so that I can rewrite this primary equation without an r in it. And when we're thinking about building our constraint equation, we have to involve what we're restricted by, what our limitation is. And our limitation is that this cylinder is stuck inside of the circle. So basically I'm trying to relate h and r somehow to the only piece of information I know about the circle, which is the radius. So how do I relate r, h, and this radius here of 4? Well, I hope you're starting to see this right triangle that we're going to focus on. So I'm going to focus on this right triangle here with a base of r and then a height of h over 2. So if I just focus on this little triangle, then this distance here is h over 2. And so we have this Pythagorean theorem forming because I can see that the two sides involve r and h, and then the hypotenuse involves that length of 4 meters. So our constraint equation So this equation that relates the two variables I wanted to relate, r and h, and then also involved the restriction, the constraint, which is the circle or the sphere representation, is going to look like h over 2 squared plus r squared is equal to 4 squared. So this is my constraint equation. Let's simplify it a little. H squared over 4 plus r squared equals 16. And remember, I wanted to eliminate r, or r squared, so I'm going to solve over here for r squared. I'm going to go ahead and get this r squared by itself by subtracting h squared over 4. So r squared equals 16 minus h squared over 4. And now I can take that and substitute that into the primary equation. So this is going to come over here and get substituted in. So that volume is about to be a function of just h. I'm going to have pi. I'm going to replace r squared with 16 minus h squared over 4, and then times that extra copy of h in the back. Now this is all commutative, so I can put the h in the front, so I can have pi h 16 minus h squared over 4. And of course I can distribute this in as well. So this is 16 pi h minus pi over 4 h cubed. H cubed if I distribute this in. So now volume is a function of only the height of the cylinder.